This time things are a little bit different. You've still got 7 yellow balls and 5 red balls, all right? So let's drop that down. We've got 1, 2, 3, 4, 5, 6, 7, and 5. 1, 2, 3, 4, 5. In total here, you've got 2 sixes, 12. You've got 12 balls here. And one ball is taken from the bag and it's not replaced. This is the key word. The second ball is then taken from the bag. So what's the probability both are red? Well, if we have a look at this as a tree diagram, we've got the first ball you could choose are yellow, or you could have the first one to be red. If it was yellow, it would be 7 out of 12. If it was red, that would be 5 out of 12 as a probability. If you continued and then you took the second ball out, well, you could have a yellow again, but now this isn't 7 out of 12. The reason is because you have not replaced it. If you take one of these yellow ones out now, you no longer have 12 there, you now have 11. And how many yellows do you have? There are only 6. So the probability now becomes 6 out of 11. What about if you wanted to choose a red? Well, there are still 5. There are still 5 reds there, but there are only 11 balls to choose from. So it's 5 out of 11 now, not 5 out of 12 like it was at the very beginning. Now let's say you choose the red one. You could choose a yellow second. And now if I go back to this and I put my yellow ball back in there, but now I've chosen to take a red one. So one of these red ones has gone now. I still have 11 balls to choose from, but how many of them are yellow? 1, 2, 3, 4, 5, 6, 7. This is 7 out of 11. Because I've only just taken a red one out. There are still 7 yellow ones in there, but there are only 11 balls to choose from. What about if I chose a red and then a red? Well, now I've taken a red one out. There are only 4. And there are 11 to choose from. Notice in all of these second cases, there are 11 as the denominator. In the first case, there were 12 as a denominator. And notice that if you add the 5 and the 6 together, you get 11. If you add the 7 and the 4 together, you also get 11. This is something to check when you're doing this. Now we've drawn the tree, we can look at our questions. What is the probability both are red? So we go along the red, and a red and a red would be multiplying them together. When you go this way on a tree diagram, you multiply them. So on the numerator, you'd have 20. On the denominator, you have 132, and this is how I'd leave my answer. So the answer to part A is 20 out of 132. Now what about for part B? Both of them are the same colour. You could have a red and a red, or you could have a yellow and a yellow. And this probability, if you multiplied them together, you get 42 out of 132. Now the reason I'm not going to cancel these fractions down is because I now need to add them together. And if I had cancelled it, then I would find it more difficult to add them, because then it would have different denominators possibly. So now I've got the same denominator, I can simply add these together. So both of the same would be this one or this one. I'd get 62 out of 132, and that's part B. For part C, the probability that they are different colours will be every probability minus the one that I've just done in B. So the answer to part C is going to be 1 minus 62 out of 132, which is 70 out of 132. So that's the answer to C. And the answer to D, the probability at least one ball is yellow. That could be a yellow and a red, or it could be a red and a yellow, or it could be a yellow and a yellow. Now remember that there are only 4 possibilities. There is also the red and the red, which I'm not including. But because this list is smaller, I would do the trick I mentioned before, which is 1 minus the one that I don't want, which is the 20 out of 132. And by doing 1 minus the one I don't want, I'm working out the probability of the first 3, but in a very simple way. So by doing 132 minus 20 is 112. This is 112 out of 132. And that's just a quicker way of getting there.